Hello, I'm Mr. Hotelling, and welcome to this installment of Numbers in Physics and Chemistry. So we are currently going to be looking at question 1.2, which is one of the 5 different places from which numbers come. We have already spoken about the different types of numbers, discrete and continuous, and where counts come from and the significance and significant digits of them. We are now going to talk about mathematical constants. If this is the first episode and installment that you've looked at, you may want to look at the prior installments. So mathematical constants. Things to know, we'll point right off the bat, is that they are exact. They have infinite precision and an infinite number of significant digits. Notice this asterisk here. So let's take a look at our first mathematical constant. Our first mathematical constant is this 1/2 in this area of a triangle formula with which most of you are probably all familiar. So the question is this 1/2. Could this be 1 over 1.9 or 1 over 2.1? And the answer is no. It is exactly 100% precisely perfectly 2, and here is why. This formula for the area of a triangle comes from the area of a rectangle, which we probably recognize. The formula is length times width, which could be written as base times height. Base times height, or length times width. The idea is that the area of the triangle is exactly 1/2 that of the rectangle. Not 1 over 1.9, not 1 over 2.1, exactly 1/2. That's exactly what it means. So this 2 in the 1/2 is perfect, it's exact, it has infinite precision and an infinite number of significant digits. So if we were to rewrite this number as 0.5, it doesn't just have one digit, it has an infinite number of digits going in that direction. So that is why this mathematical constant is exact, has infinite precision, and an infinite number of significant digits. If we are now to look at this formula, which some of you may have encountered if you've taken physics before, or if you are taking physics, you will learn it. There's this 1/2. It turns out this 1/2 is exactly the same 1/2 as the one above it. It comes for the same reason, and that will be revealed when you learn more about physics. But this 1/2 here also has infinite precision. It has an infinite number of significant digits. This next number, pi, and this is where the asterisk comes in, why there's an asterisk on that. It turns out pi is a number that does have an infinite number of digits. And it turns out that pi has recently been calculated to 64 trillion decimal places. Now, for perspective, if you were to try and write out those digits, write out this number, all 64 trillion of them, it would take you longer than your entire lifetime, even if you never slept. That's how large that is. And it keeps going. And it goes on toward infinity. So this number pi does have an infinite number of digits. However, because of the nature of this number, we use an approximation, a certain number of digits. If we use this many, it's 3. If we use this many, it's 5. If we use this many, it's 9, and so on and so forth. So this mathematical constant is exact. It does and can be known to infinite precision, and it can have infinite a number of significant digits. However, we will choose the number of significant digits to use. Similarly, there is this value g. It's called the gravitational field strength. How strong the Earth's gravity is at the surface of the Earth. Now, this number is generally taken to be this number, which has 6 significant digits. We very often, however, will use 9.8067 or 9.807 or 9.81 or 9.8 or 10. The number of significant digits we use will be a choice that we make. it has much more precision than the number of digits we would choose. So this one is like pi in that we choose the number of digits to use. It is unlike pi in that it does have a finite number of significant digits that is usually more than the number we will use. Another number, for those of you who've taken chemistry, this number here, Avogadro's number, you'll notice it has 4, 7, 9 digits. And this is treated very, very much like the gravitational field strength, this Avogadro's number. The number of digits it has and the level of precision it has depends on what we will choose to use. Most of the times in schools, we will use 6.02 or 6.022. So usually it would have 4. It doesn't have infinite. It does have up to 9, but we would use somewhere in the realm of 9. So when it comes to mathematical constants, if it's in a formula that we know, particularly a geometrically derived formula, it will tend to be exact and have infinite precision, may have an infinite number of significant digits. There may be some constants that we have or use that have an infinite number of digits, like pi or the square root of 2 and so forth, that have an infinite number of digits. We're going to choose to use a particular number of them. And there may be some other constants that have a large number of digits, and we will choose to use some number of those. In our next installment, we will talk about scientific measurements. And this is one of the areas that this installment on measurements is one of the perhaps most important. Many students enter honors or IB or AP, chemistry, college, and do not know how to make a proper scientific measurement. So we will not only learn how to make a proper scientific measurement, we will learn how to think about it in terms of how precise it is, its uncertainty, and the number of significant digits. I look forward to seeing you in the next installment.